welcome to our introduction to resistors. What is a resistor? It's an electrical component that resists the flow of electricity by limiting the flow of electrons. It can be inserted into an electrical circuit in either direction, and for the most part, with just a few exceptions, its resistance remains constant. The symbol for a resistor looks like this. The units of resistance are ohms, and the symbol for ohms is N omega. So in a resistor, the higher the ohms, the greater the resistance. A resistor might fit into a typical electrical circuit like this. In this circuit, the resistor limits the current going to the LED from the voltage source V1. There's a few types of resistors we'll talk about right now. The first is a thru-hole resistor, which is this red component here. This resistor is made for a high voltage setting, which is why it's so large. It's also about 90 years old. Here we have a more modern resistor, also a thru-hole resistor, but it's made to operate in a much lower voltage circuit. On either end are the terminals, which go through a circuit board, hence the name thru-hole resistor. Also, a modern resistor used in manufacturing settings is a surface mount resistor. As you can see, they can become quite small, in fact microscopic. Some different types of resistors are a photoresistor, which changes resistance based on light, and a potentiometer, which changes its resistance based on the dialing or turning of this knob. So what's inside a resistor? In its most basic sense, it is a number of wire wrappings around a core. The numerous wrappings of the wire create a more labored path for the electrons to travel down, which is why this component is able to do what it does and resist. Okay, so we're going to measure the resistance of some of the resistors we looked at earlier. To do this, we're going to use our multimeter and we're going to set it to the omega or ohm symbol. We're going to take our probes outfitted with alligator clips and affix them to the terminals of the resistor. So this resistor measures about 3.2 mega ohms. That's a lot of resistance. For comparison, we'll look at our other thru-hole resistor, which only measures about 105 ohms. Our photoresistor looks like it measures about 3.1 kilo ohms. But when you shine a light on it, the resistance decreases. The potentiometer starts out measuring about 10 kilo ohms. But as you slowly turn the dial, you can see the resistance decreases. Pretty neat. So here we have our circuit that we drew earlier. We're going to be using our Arduino board as our voltage source. So we have V1 going through our resistor to our LED and then back through ground, completing the circuit. In this circuit, our resistor is limiting current going to our LED. So this resistor is about 0.9 kilo ohms. So if we were to replace it with a smaller resistor, we would be allowing more current to go to the LED, and it should get brighter. So if we take our 105 ohm resistor from earlier and place it in line, we get a brighter LED. So that's about it. Thanks for watching.